Hello students, so we'll move on with the next scheduling algorithm, that is round robin scheduling algorithm for the same second problem. Here the time quantum given is 3 milliseconds, time quantum or time slice. So what is the meaning of time quantum is each job or process at a time it can execute. Now in this case at a time it can execute for 3 milliseconds. Okay, so we'll see how to do this. So for our simplicity we'll write like this: J2, J3, J4. So it goes like this clockwise, and we'll write the burst time for each of the process, then 3, then 5. Okay, so we'll draw the Gantt chart now. So beginning with arrival time equal to 0. At arrival time 0, you have only one process J1. So you'll allow J1 to execute, but for how many milliseconds? For 3 milliseconds. Okay, so this will be executing for 3 milliseconds. Okay, for 3 milliseconds you can execute. So actually it requires 6, but out of that 6 only 3 millisecond it can execute. Okay, so that is one thing. Next, which is the next process, that is J2. J2 requires 5 millisecond, but at a time it can execute only 3. So this 3 plus 3 6. So here 3 is gone. So 2 is pending. Next will be J3. Again 3 milliseconds. So it requires only 3 milliseconds. So it is done completely. So J3 is done. Next you have J4. Again it takes 3 millisecond. So 2 will be pending. So it goes up to 12. Next you have J1, which only 3 is pending. So then we are done with J1. So it goes up to 15. Next you have J2, only 2 milliseconds remaining. So it goes up to 17. Again you have J4, only 2 milliseconds. So it goes up to 19. So this is your Gantt chart. Okay, so verify 19 to sum of the burst time, that is 19. Now calculating the waiting time. So here calculating the waiting time you have to be careful, since a particular process comes many times in the blocks. Okay, so for J1, what is the waiting time? J1 came in at 0 millisecond, got the CPU at 0 millisecond. So 0 minus 0. But you can see J1 is there once again over here. So how you have to do here is, it started at 0, it executed till 3, then it stopped. Some other process was executing in the CPU. Then once again it got at 12. So how we have to do? When it stopped and when it got. Okay, that difference. So 12 minus 3, because at 12 it started again, and here 3 it had finished and 12 it got again. So that difference is waiting time. So how much you're going to get? 9. So that is 9 milliseconds. Next is J2. J2 came in at 3 millisecond, got it 3 millisecond. So 3 minus 3. Again where you have J2 over here. Okay. So it executed till 6 and again it got at 15. So 15 minus 6. 15 minus 6 is how much? This is 0. 9. 9 milliseconds. Okay. Next you have J3. J3 came in at 3 millisecond. It got at 6 milliseconds. So 6 minus 3. Again, do you have J3 anywhere? No. So 6 minus 3 is 3 millisecond. Next you have J4. J4 came in at 5 millisecond and it got the control at 9 milliseconds. So 9 minus 5. Do you have J4 once again? Yes. So plus. It executed till 12 and again it got it 17. So 17 minus 12. So how much it will be? 4 plus 5. That is equal to 9 millisecond. Now you have to calculate the average waiting time. That's nothing but 9 plus 9 plus 3 plus 9 divided by 4. So how much you're going to get? 39 by 4. So whatever value you get, that is the average waiting time. Now we have to calculate the turnaround time. So how we are calculating turnaround time? Burst time plus waiting time. So J1, J2, J3, J4. Write the burst time which is given in the question. So you have 6, 5, 3, 5 plus the waiting time you are going to get here. So 9, 9, 3, 9. So how much you are getting? 15, 14, 6, 14. So average turnaround time is nothing but 15 plus 14 plus 6 plus 14 divided by 4. That's equal to those many milliseconds. So this is how you have to do the round robin scheduling algorithm.